BS 要全國免費㗎嘛。
Sorry everyone, I have a tough day today. So I literally run here. TMBR. Okay, so let's just start. So my name is Lucia Chan. I think some of you have seen me in some of the conference talk, and I am a PhD candidate of in University of Edinburgh School of Informatics, and I'm leaving Hong Kong on Wednesday, so I'm giving this farewell lecture. And I was a psychologist, and I self-taught myself programming, and I was a data scientist as well when I was doing my Master of Psychology. Okay, so this lecture will cover all the foundation skills of being a data scientist. Sorry, I need to get my notes now. The talk is too long. Okay, so I will mainly just introduce how to use R to do all the data science analysis. But you can, if you are familiar with Python, of course, you can replace those skills with some of the Python packages like pandas, if you know that. Okay, now let's start with R nuts and bolts. How many of you have experience of using R before? Are you all programmers? Not a lot of you. Are you all programmers? Most of you. Okay, that's great. This is an elementary skill level talk. So let's start with the basics. Now the basic, the most basic object in R is a vector. So a vector. How to create a vector? Use a vector function. Now, once you create a vector, you can store objects of different classes. For example, numeric, logical, character, and integer. You can just create this object, different classes in this way. I share these slides on Facebook, so you can access all the content over there. Okay, so another object I need to introduce is matrix. It's a dimension vector. I guess most of you have some experience of like what is a matrix. Okay, another one is very important. It's a list. A list is a vector that can contain elements of different classes. Now, just to remind you that for vector usually only contain objects of the same class. If you want it to be different classes in the same vector, you need to create a list. For example, like this. There's a numeric, a logical, and combined. Okay, so list is very important because it can combine with various apply functions. Now you need to check the apply functions in R. It's very convenient. You don't need to always write a loop like what you're doing in Python. Lapply, for example, I just introduced lapply. There's sapply. Homework tonight is to search what is that sapply. It's similar to lapply. So what does lapply do? It loops over a list, iterating over each element in that list, and it applies a function to each element of the list and returns a list. So it's very convenient to just use lapply to loop through a list. Okay, now next one is vector. Vectors are used to represent categorical data and can be unordered or ordered. So a vector should be categorical. Now you can change the name of the levels. So the level names indicate the names of the category. So you can change the level names with this function easily. Okay, next one. Well, a lot of you should be familiar with data frame. It's kind of similar with matrix, but it's different. So data frame stores the tabular data. Do you know the difference between a matrix and a data frame? Any idea? I'm not asking you. And okay, so with a matrix, you can only store all the columns with the same class of objects. So if it's numeric, all your matrix should be in numeric columns. But for a data frame, you can store whatever classes of objects you want. You can have one column of numeric, the other column characters, etc. So to do data manipulation with a data frame, I would recommend you to use a package called dplyr. And you should do your homework tonight after the talk. What is dplyr and what are the basic commands over there? And you can also install a package called tidyverse, which contains a bunch of packages, including dplyr and ggplot and whatever. Also, reshape is very useful, and data table is very useful as well. So these are the packages for your references if you're doing data manipulation. However, if you're doing data manipulation of a matrix with Python, you can just install pandas, and that does everything. Okay, so time. Another object I need to introduce. This one is a little bit tricky. It's time and date. So why is it tricky? I'll tell later. So time and date are objects. Dates are represented by the date class, and times are represented by the poset class. You can coerce a date object from character. This is how you coerce it. Now, why it is so tricky? If the time you have is already in a poset format, you can easily convert it to a poset format object with this function. However, in most of the case, it could be different. Sometimes months is the first one and the date is the second one, so time can come in different formats. So what if the time object is not in poset format?
You can continue. I just tilt the screen a little bit so that the live stream can catch your face.
So it wasn't catch your face. Good. Okay, so now you can use a function called strip time. So what strip time do is to define like the format of the time object. So you can define it by day, year, month, and also hour, and also time. So you can define it and then convert it to a poset object. Okay, so a question for you. Now, since you have the time and date object, how to compute time difference? For example, I want to know how many days between between 23rd August 2016 to today. So how to compute it? You have two objects. You can just do subtraction. Yes, that's easy. Yeah. That's how you do it. Okay, now we finished the last part, the R nuts and bolts. So you have a basic idea of what are the functions in R and how to do data manipulation. Whether it's easy, right? If you are already a programmer, you should acquire those skills quite naturally, I would say. Okay, so now here's data scientist part, data science roadmap. If you are working on a project, you might find being a data, if you're an engineer, like website or apps engineer, you might find being a data scientist is quite different. The first step you need to do is to frame the problem. So what is framing a problem? That is to make a hypothesis. Do you have any idea of what is a hypothesis? For example, if the weather is hot, there might be correlation between the temperature and the amount of ice cream people consume, sort of like that. So a hypothesis that there is a positive correlation of that. So you frame a problem. Of course, this is a simple one. It's not in a business model, but you can frame any problems in your business models. Okay, and then you understand the data, extract features, and the last part, which is I think most of you will be very interested, building a model using machine learning. Okay, so now before you look at the data, you need to ask yourself a few questions. Well, actually, there were a few of them, and I just listed two in case the questions are too overwhelming. So, how big is your data set? That is very important. For R, if you're using R, there is a limitation of RAM. So, if your data set is quite big, you might need to use a different approach. For example, I will introduce how to do the big data analysis at the last part, like cluster service or what kind of package you can use. And also, are there any duplicated or any incomplete cases and where they come from? Now, it's easy for you to notice duplicated or incomplete cases, but why do you need to know where they come from? Because if you're collecting your data with a survey website, there could be bugs on the website and you don't know. And you will find the bugs through your data. So it occurs to me on my studies before. So just want to remind you, you need to check the data before you actually do any exploration or analysis. Okay. The most important question is whether the data set can solve the problem that you are trying to tackle. So it's not like you have a set of data and then you have a question. The set of data must provide clues to your question or your hypothesis. You need to have domain knowledge. That's what you need to require as a data scientist. For example, if you're predicting a stock market, you might need to have economic background, or you work with people with this background. It's not like you've put whatever features in the model and the models will run out a best result for you. You need to consult some expert in the domain knowledge or yourself is an expert. Okay. Now let's see what is data wrangling. The process of getting the data from its raw format into something suitable for more conventional analytics. Now, most of the data you collect is stored in some sort of database. So here I just put up an example, the Mongo database. I built an app and I use a Mongo database. And you can use PyMongo to retrieve the data, or you can use an external application, for example, Studio 3D. Now, sorry, a little bit cold. And you can extract the data in different formats. For example, CSV or the JSON format. Do you know what is the JSON format? So it's in hierarchical structure, and if your data is in hierarchical structure, I would highly recommend you to export it with a JSON format. And I would say it's very easy to do any manipulation just with the pandas package in Python. Okay. Now, okay, so after you extract the data, you need to do some data exploration. How to explore your data? You do some histogram and scatter plots and see if there are any outliers. Are these numbers realistic, given what you know about the real life situation? For example, I gave you an example of the correlation between weather and the consumption of ice cream should be positive. So this is what you know about a real life situation. And then when you explore the data, you need to see whether these numbers are realistic or there could be bugs of your survey website again. Okay, take some simple questions that you already know, answer them based on this data and see if the results agree. Okay, so data cleaning. How to find out the outliers. You can do a box plot. Here shows 25 and 75 percentile and the median and some outliers in here. So it's easy to do it with a box plot. And if you're cleaning, oh well, there's one thing that will screw up your functions. That is the NA values. If you're calling the mean function, mean sum quanta, this function, if there's null values in your data frame, the result could be NA. So how you're going to do it, it's easy. Just use NA remove. And if you're not using these functions, because you can use NA remove in mean, sum, quantile, etc., standard deviation. But if you are not using these functions, you can use complete cases function, detects rows in a data frame that do not contain any missing values. So it's also easy. Okay, now after you do the exploration and then you want to do more, for example, you want to do more with visualization. A very important package you need to check is ggplot2. So your homework tonight, check what is ggplot. Now a photo, if you're a data scientist, well, most of you are not. So if you're doing any analysis and you're presenting your project, a photo is worth more than 1,000 words. Here's an example for you. So I used a data study. I collected Weibo. Do you know what is Weibo? Status from thousands of people. And these people also filled in a measurement scale of how depressed they are. So I would call that depression score. So they filled in the scale, and I received their agreement. They granted me the right to retrieve their data on Weibo. So here I plot their sentiment. I do a sentiment analysis on their Weibo, and then I plot their sentiment and the depression symptoms according to the date. Now 900 means it's like 900 days, 3 years, almost 3 years. The red one is a high symptom group, people like with a high score, and the blue one is a low symptom group. So we can see that people with high depression symptoms actually have wider range in emotion, like they can be very happy and very depressed. It's not like bipolar, but very happy and very tend to be less stable than the low symptom group, I would say. So if you have a graph here, it's easy for you to understand. Now here's the example of using ggplot. Okay, so the line plot is also very useful. Here shows depression symptoms and sentiments in both 3 years, and 3 years and 1 year. For the high symptom group and low symptom group, well, you can see that the valence is also the sentiment. The sentiment of the high symptom group is always lower than the low symptom group. So, well, people with more depression symptoms, they tend to be less happy. Okay, so you can see the 3 year also agree with the 1 year. So they're not just depressed suddenly. Actually, they have been depressed for a long time. Well, we call that dysphoria. Okay. Now, this is the exciting part. Doing classification. Now, after you retrieve after you explore the data, now you're going to build a model to classify your data. So, machine learning. There are generally 2 categories: supervised learning and unsupervised learning. In supervised learning, your training data consists of some points and a label or target value associated with them. So there should be a label on your data. For example, you manually rated the movie reviews. The mark you rated, that is a label. So unsupervised learning means it's just raw data without any particular thing that is supposed to be predicted. Okay, so for unsupervised learning, you usually do it with like data exploration, or you want to find features in the data. Okay, before you build a model, you need to know that one big problem you will be facing is overfitting. What is overfitting? That means your results look great for the data you train them on, but they don't generalize to other data in the future. Now, how to detect that? There are two ways to do it. Usually, you randomly divide your data points between training and testing set. For example, you set like 70% of the data randomly withdraw from the sample as training set, and the rest of the 30% is the testing set. Now, the next one should be more accurate, and if you're doing academic, we usually use the next one. K-fold cross-validation. What is K-fold? It means you divide your data into K-fold, and then you each time you train the model on like all the folds except for one, and you use the one for testing, and you repeat this process many times. At the end, you aggregate the result. That is K-fold cross-validation. Okay, now if you find there is a problem, overfitting in here, how to solve it. Here I just briefly provide some solution. You can try getting more training examples. You can try a smaller set of features. You can try a larger set of features. Now, if you are in an advanced level, you can do gradient descent, which is to plot all the models and select the best one. Okay, the best features. Now, how to select the features? This is critical. It's critical to know how to select the features. The best features are the ones that carefully reflect the thing you are studying, so you're likely going to have to bring a lot of domain expertise to your problems. That's why you need to work with expertise. Okay. Right. Now, if you are feeding a lot of features, you have a lot of features, and you don't know how to select it, you feed all of them in your model, what would happen? Now I need to introduce the curse of dimensionality. Now, what is the curse of dimensionality? Now, if you have multiple dimensions on your data set, you can see here we have 3 dimensions. The dots, the distance between the dots are actually quite far away. Imagine if they are all on the same dimension, the distance between the dots could be quite close. So why this is a problem? First of all, it's hard for you to figure the pattern if it's quite sparse. Now, if the distance are quite far away, you will say this is a sparse model. And in a sparse model, it's very difficult for you to figure out the pattern. And it takes more computational capacity to do that. And loosely speaking, a sparse statistic model is one in which only a relatively small number of parameters play an important role. For example, you can see that this is a sparse model. From this point of view, they are in a cluster. So these C and A, they might be outliers. So you tend to focus on a smaller number of parameters. So then we need to reduce the dimension. Now, one way to do that is to use principal component analysis. So every point on the x and y axis is like this. If you want to reduce it to a single dimension, you can do a principal component analysis, use this function to do that. So you don't need to know how to do the function, but you need to understand why we need to use this and how does it work. Another way is k-means clustering. So what is k-means clustering then? Now, suppose you have a data set. You randomly assign k in this data set. K here is 3. And then you associate all the other points to the K. Okay, so then you have 3 clusters in here. And then you for each cluster, the mean moves to the centroid. This is the K-means clustering. Okay, so these are 2 ways of reducing dimension, and there are many other ways. To save time, I just introduced 2. Okay, so then you need to build a classifier. What is a classifier? It gets trained. Once it has been trained, the classifier acts as a function that takes in additional data points and outputs predicted classifications for them. Okay, so I will introduce a few classifiers that are commonly used by data scientists. The first one is this decision tree. Now, the tree structure is very simple for you to understand. There are nodes in here. For each node, you ask a question. For example, if it's a numerical node, you ask a question of whether it's above or below a threshold. And then there are child nodes that corresponding to the answer. And if it's categorical, then you ask a question of each category, and there are child nodes corresponding to the categories. Now, the problem of this model is that if you are running decision tree, you probably build a lot of trees. But it's difficult for you to control, or to find the best tree model and to control the depth and the depth of the trees. Okay, so a more commonly used model should be random forest. A random forest is a collection of decision trees, each of which is trained on a random subset of the training data and only allowed to use some random subset of features. When I was doing this slide, I was in China, so I couldn't find an appropriate graph for random forest with Baidu. So I used the one on my previous paper. This is a model of me. I built a model to predict satisfaction with life using Facebook status update. So I request a lot. I asked a lot of people, thousands of them, to self-report their satisfaction with life score, and then I collect their Facebook status, and then I extract features from their status, and I reduce the features by lasso regression. It's a type of regression. And then I fit it into a random forest model where each time the model selects a subsample and build a trees. And then eventually you aggregate the results. So this is random forest. Okay, so another model I need to introduce. This is also very commonly used by data scientists. It's called the support vector machine. The support vector machine, SVM, assume that all the data, assume that your data set can be divided by a hyperplane. It's a linear hyperplane like this, and this is called linear separability. So this is a function, and W is a vector perpendicular to the hyperplane, and B measures how far offset it is from the origin margin. Okay, so now it's easy to understand this one. But what if your data looks like this? You can't separate with the linear hyperplane, and then you need to use something called the kernel trick. So the idea of kernel as SVM is to first map our points, data points, to some other space in which the decision boundary is linear, and then construct SVM models. that operates in that space. Okay, now the next one I'm going to introduce is the naive Bayesian. Bayesian statistics is one of the biggest, most interesting, and most mathematically sophisticated areas of machine learning. Now, this one I'm going to introduce is naive, so it's quite simple. But the very fancy deep learning stuff also belongs to the Bayesian statistics. Okay, so assume that we have a fictional data set that describes the weather conditions for playing golf. It's not unspecified. Golf. Okay, so we have variables: the outlook, temperature, humidity, windy, and we have a label here. So we need to predict the labels. Are you going to play golf or not under these weather conditions? Now, first of all, you can draw a frequency and probability table for the weather data. The probability of you playing golf in a sunny day is 2 divided by 9. Not playing golf on a sunny day is 3 divided by 5. If you look at the data again, you can actually count it. 2, temperature, no. So it's, okay, it's no, yes. So 2 yes. Okay. 2 yes among 9 times, right? Okay, so now assume that we have to classify the following new instance. For example, it's on a sunny day, temperature is cool, humidity is high, it's windy. Will you play golf? Now let's build a model. Now we find out the probability of playing or not playing the golf under different situations, and then compute a probability for each class based on the probability distribution in the training data. First, take into account the probability of each tribute. Treat all tributes equally important and multiply the probabilities. Now if you multiply the yes, the one I highlighted in red. Okay, this is the first one, probability of you playing it, and then you multiply the no's. This is the probability of not playing it. Okay, and now take into account the overall probability of a given class. Multiply it with the probabilities of the attributes. Now, if you look at the table here, you will find the probability of you playing golf in general is 9 divided by 14. Not playing is 5 divided by 14. Okay, now you multiplied it. Now chose the class so that it maximizes its probability. Okay, which one is bigger? Is a higher? So it's a maximum probability. Now you will choose no in here. So the new instance will be classified as no. Is it confusing for you, or is it clear? It should be. Now, if you're not clear, you can go back to the slides after the talk. Okay, so the next one is a neural net. This is a neural net. The simplest neural network is a perceptron. This is called a perceptron. A perceptron is a network of neurons. Do you know neurons in the brain? Neuron is a cell. Okay, so for each neuron, each neuron takes in multiple inputs and produces outputs. All layers neurons before the last one are called hidden layers. Now, each neuron itself is a tiny logistic regression. If you know what is logistic regression, if you don't, you can read some more books about it. Okay, so here are the classifiers. We introduced 4 commonly used classifiers. Now, after you build the classifiers, you need to evaluate your model. How to evaluate your model? You can use a confusion matrix, a matrix like this, to indicate predicted labels, and the labels should be where it should be. Okay, so another one that is more commonly used by data scientists is called ROC curve. I actually have the full name of the ROC curve in the new version. This is probably not the latest one. Okay. Okay. Yeah, it's too long. Okay, so for the ROC curve, now you can see that the best models, if you plot all your models as a curve, the best model should be at the left upper corner. And any classifiers fall into this triangle is basically just useless. Okay, so a curve. The best curve should look like this with a sharp angle at the corner. And a standard way to score the curve, to see whether the curve is good or not, is to calculate the area under the curve. And a good classifier will almost fill the square and have an area, AUC, area under the curve of near 1. Okay, so, wow, that's fast. Finally, we come to the last one. Now, I just mentioned it at the beginning. If you are doing big data analysis, you can use the cluster service provided by Amazon Web Service or Azure. I used Azure before, and they have an R server. It's very easy to use R with Azure. And you can use Google Cloud or Ali Cloud. I haven't tried it. Okay, so if you don't want to spend money, you can try other packages. RSQL, for example. You can just push all the SQL data in R. And you can use Sparkly R. You connect R with Spark. Usually you do that with a cluster because you don't have a Spark in your at home or in the office. So you just do it with a cluster service. It's basically the same. The process of analysis is the same. It's just you need to use a slightly different package approach to do it. Okay, so this is one of the references actually. And thank you. Wow. It's actually half an hour. I thought like it would be 1 hour. Okay, so
you have half an hour for Q&A.
okay, so great. Do you have any questions for me? Yes.
Maybe I think to talk about some techniques, maybe regression or other
Regression.
techniques.
Okay.
The slide is
Too simple.
Too fast.
Oh, too fast. Right. I haven't prepared for regression, but I can actually talk about what is linear regression. Maybe I can draw it here. Well, can I draw something? Or can I just, oh, maybe I should just draw it here. Well, I actually, oh, is there any drawing pad that I can draw a graph?
Okay.
Yeah, I can just show you like the Microsoft Paint thing. As long as I can draw a XY axis,
Okay.
it's fine.
Okay. The easiest way is to Google it.
Okay.
Oops.
see.
Okay, yay. Alright, this is a very simple version. I hope you don't mind the cranky drawings on here. Now, how many of you understand what is a regression? Linear regression. 1, 2, wow, quite a lot of you. There are like 5. Okay, so we have X and Y axis. Now we have maybe, I don't need to draw this actually. Okay, I have many dots as data points. Pencil. Oh, wow. Bigger, smaller. So these are my data points. Oh, they're quite big. Okay, oh, there are a lot of them in here. Wow, it's hard. Okay. Now, for linear regression, well, it's actually, I would say, if that reminds me of the SVM model, you actually need to draw a line to separate the data, just like the SVM. You use a hyperplane to separate the data. Now here, linear regression, you fit a line to separate. Not like this. What is this line? It has to be straight. Okay, like this. Now you use a computer. The computer will fit in many lines. Not a good drawing tool. Okay. So the computer will fit in many lines in here. Then the algorithm will look for the best one. The best one should have. Now here this is the distance between the points and this line. If you sum up the distance between the points and the line, the best line should have the shortest distance.
Should that be the tangents or just a line?
Just the distance of the line, not the tangents. Yes. Now this is basically the concept of a linear regression model. And there were many types of regression: logistic regression, lasso regression, and they have you use it for a different purpose. Okay, so what other questions?
How will you present your result? Maybe you say you have maybe you have done many analysis and then you have some result. How will you present the result?
Well, then you must go back to the data visualization in here. So, oh, it's a browser or this one. Yeah, the best way to present your result is to visualize your data. You create graphs. Now, here I introduced 2 types of commonly used graphs: scatter plot and line plot. And there's also heat map, histogram, whatever. So use graphs, and depends on your presented to what kind of audience. Are they academics or are they business people? If they're academics, they like a report. If they're business people, of course they like graphs.
So are you specify? Is your question more specific to the machine learning problem, right?
Okay.
If you're talking about machine learning problem, there are specific way to present the results, which is to to present the performance of the machine learning model, like using the confusion matrix to show your model is accurate. That cannot be displayed using simply background.
Or you can use a ROC curve to show how good your model is.
No, I mean, during your research, maybe you have maybe you analyze some source file, something. You may have done so many things. Something may be useful or maybe not interested. So how will you organize this kind of thing?
Well, do you mean like the things that I am interested or the audience will be interested? That's different. Like sometimes audience are interested in something that I am not interested. Okay, I'll give you some time to organize your question.
So in the data scientist roadmap, at the very beginning, you say you define the problem and understand
Frame the problem.
etc. So can you make use of this roadmap to explain how you did the Facebook project?
Oh, okay. Frame the problem, understand data, extract features, build models. Okay, this is my Facebook. Now, the problem here, I make the hypothesis of like we can predict users' self-reported satisfaction with life with Facebook data. So I don't know like what kind of features I can do when I make the hypothesis, and then I explore the data, do clean the data, whatever, and then I do feature extraction. So this will go to my domain knowledge. So I know that the sentiments is highly related to in psychology we call it valence. It's highly related to self-satisfaction of life. And the LIWC, if you know what in natural language processing, that LIWC contains 60 categories, psychological categories, including positive affect, negative affect, health, family, whatever, 60 categories. And I do a LDA topic modeling. It's called Lantern Directional Allocation Topic Modeling. That means you find topics among the text with an algorithm. So I find like 2,000 topics among the text. And then I use lateral regression to select useful features in all these variables. Here I have 2,000 features in the LDA model. I have 65 features in the LIWC model. And I feed them in the lateral regression and select about 100 something. I forget how many of them. And then I feed these features to the random forest model. And then runs out the result. What is that? That is modeling. Yes. I think that explains how I did it. Yes,
So
extract features.
So in this research, what you're working on is to see if your hypothesis on the relationship of
Yes.
Facebook status to their
Yes,
happiness.
and then my model, the accuracy is about 40%. Well, in we have previous studies using Facebook status update to predict personality, and accuracy is about 40-something, 50%. So basically, if you are using social media data to predict psychological variables, the accuracy will be about just 50.
So do you think it's a proof or it's a proof finding of the
Well, of course, you well, we use a p-value to how to say it. We our p-value is weighted. So we prove the hypothesis
So
in here.
is it usually in data scientist work, it's going to be like, for example, you put a hypothesis and try to prove it or try to disprove it, something like that.
Yes, you can prove it or
Is it going
disprove
to
it.
be possible that if we have a bunch of data that we don't frame the problem by human, but it might hint you that some kind of problems that
Then you are
might
phrasing the
discover-
problem.
Then you discover some. So this is like, so it is still we need to frame the new model and then try to build another model to test it, right? What do you mean?
From my understanding of what you're talking is like you have a bunch of data and you're looking for a problem that you can
Or maybe
work on.
Or maybe at the beginning we look at one problem, and maybe we found that it is
Yes, you can have multiple problems and you build multiple models to predict it. You don't build one model to predict everything. You build multiple models to predict. Yes.
Thank you.
A question is, up front you mentioned you self-taught yourself programming and data science. Would you mind sharing?
Not data science. I actually had statistics in my undergraduate degrees and my master degrees.
Okay, so would you mind sharing a bit more about your own journey in this whole process? Just a quick.
Whole process.
How did you?
How did I self-taught?
Yes.
Well, it's not literally just self-taught actually. I took some Coursera courses. I read some books, and the most important thing is that I had the best friend who is a top data scientist and very good at programming. And I asked him about like every question that I encounter when I'm doing programming. So he's like a private tutor, and that helps a lot. Yes. Well, and also Stack Overflow.
Oh,
Yes, that is the best place to learn. Any other questions?
did you try some deep learning techniques? For
Deep
example,
learning?
Did you try TensorFlow?
No, haven't. Yes, I want to focus on the fundamentals, and I will try it while I can attain the advanced level one day.
How much data you usually face in the problem, or how much data do you need to obtain before you are confident that the model is reflecting some stable enough?
Well, how big your how big your sample size is, it really depends on your problem. Now, if your study is something about biology and you need to do experiment on the rats or human, and usually for that kind of sample, dozens or hundreds is already a lot. Yes, but if you're using machine learning to predict, like for example, social media data, you use social media to predict personality, etc., and then you need to use a lot of data. But I think Chainsaw and Chris will have a better explanation of how big the sample size is the best for your study.
Okay, so what's your question again?
So, usually, how big the sample size is best for your study?
Okay.
Yes.
The more you have, the more better.
Bigger, the more the better.
Yeah, the more
Okay,
better.
so
because,
usually.
you can always account for if you have too much.
Hmm.
But you have not enough, then there's nothing you can do.
Yes. But well, if you're doing biology and some psychological testing on human being, you don't have a lot of subjects. So dozens or hundreds should be fine. No, well, if you're doing other stuff, maybe thousands, millions.
For example, in your Facebook example, you have like 100 to 200 features.
Yes.
So you will need like a double or maybe 10-fold of people to work the number of
I
features.
had nearly 4,000 people.
4,000 people for 200 features.
And actually, Well, how many features were your sample size?
I think someone said that you probably need at least 10 if you do regression, at least 10 observations for each feature you put in for linear regression. And now you usually can put in more features because you do feature selection. So if you do something like screening, you can somehow keep the dimension T-main. So that's how it works. So for example, Lucia use Nasu, so that's one of the regularized methods. So it somehow magically helps you to select some variables and that reduce the requirement on the number of observations required.
And actually, she used LDA as well. And LDA is a method to summarize. Actually, she should have a lot of terms or words in the tweets. Actually, it should be like 3,000 features, and then use LDA to combine it into topics, so that it reduce the space from the terms to the topics, and the topics should be much lower dimension than the terms space. So actually, she is trying to do the dimensionality reduction using topics model.
Okay, like she likes my lecture maybe.
One more thing, do you have a slide on quick data? Quick data is from your.
Oh, I think so. I did a talk with Microsoft, and I demonstrated how to use a cluster service, Azure cluster service during the talk. So that is the big data analysis talk I did with you. Were you there? Okay, so maybe I can also send a link to our community. So how about, do you have any important news to announce in our group?
I will step down.
So maybe you should come here and announce the news formally.
Yeah, I will step down, and I will not be the organizer of the RUG after this event, and I will hand over the management to Chris and Jane, but Jane is not here today. And so the future activities will be in the hand of Chris. There will be a lot of great activity in the fall of this year. So stay tuned. Yeah. And what else?
So if there's any interest in what topics you would like to hear, then I might try to find some more news. There are lots of people wanting to hear something that not enough people to talk. And so if you have something you can share, you're also welcome to share as well.
Yeah.
Please let me know. And earlier this year we won a course on machine learning for beginners. And if there's any interest, then please also let me know. And let's see if we can have some short wins again.
That's it.
Shane Slow, will you give us another lecture before you go?
Farewell lecture.
Another lecture from me. So it's embarrassing for me to organize my own.
Should we
Chris is
please
here.
organize your farewell lecture?
Yeah.